Well, great. Nice to see everybody there. My name is Aaron Gunnarsson with PHMass, Massachusetts. Thanks for joining us for our April PHMass monthly meeting. This topic for tonight is on non-residential passive houses, something we don't, I think, talk about enough here at PHMass, Massachusetts. A lot of our conversations and presentations have been really based on residential buildings, both small ones and large multifamily residential buildings, of course, but really on residential projects. And it's nice to be able to sort of dedicate an entire session here to talk about other types of buildings. Because as we all know, and I hope those who don't are learning tonight, passive house doesn't mean house. It means passive building. Any building can be a passive house. So those are the topics for tonight. Once again, use the chat room as the meeting goes on to just say hello to folks, introduce yourself if you like, ask questions, make comments, that sort of thing. After the main presentation, we will open the floor to questions, and you can use the raise hand feature and ask questions directly as well, or just continue to use the chat room. But it is really nice to see everybody here. And please, for kind of the duration of the meeting until we get to the raise hands going, just kind of keep yourself on mute. But we're going to head and get started. We're going to start with some announcements about some upcoming events and things that have been happening here in Massachusetts. So first, some events upcoming. I want to make sure everyone knows about the Certified Passive House Designer course that's going on right now. These go on throughout the year on demand, but the Passive House Network recently organized one specifically for us here in Massachusetts and Connecticut and some Northeast states, but they're really focused on Mass and Connecticut. This is ongoing. It started on March 31st, so you missed the start. But because it is a mix of on-demand and live virtual presentations, you can still enroll and catch up on what you missed. It's a great opportunity to go through the designer course and prepare you to take the June PHI Certified Passive House Designer exam. These courses are 50% reimbursement through Mass Save. That's been going on for several years. They're also eligible for some other state workforce development funding that could, depending on your employment situation in your company, tell you to up to 100% off. So really, really good deal. They have information on their site, which you can get to from ours at phmass.org. But a good opportunity to take a course like this specifically with other folks here in the Massachusetts, Connecticut, and greater New England area. There's also a couple more verifier trainings going on. I think just last month I was talking about how there weren't enough of these and we wanted to see more of them scheduled. So I'm glad to see that PHIAS is starting to put more of these into motion. So if you're interested at all in becoming a PHIAS Passive House verifier, this is a great opportunity to do. There's an ongoing course that just started this week. And these courses are a mix of in-person and virtual, sorry, not in-person, in-person, live virtual content and on-demand content that you can watch at any time. So it's sort of a blend of the two. So there's one ongoing this week, which is probably too late to join, but the next one is July 10th through 14th. So if you're all interested in becoming a verifier, or you know people who are, if you're a rater out there and looking to take another step to get involved in passive house projects, we know the demand with the new code is coming, and we're going to need a lot more verifiers. So these courses are great. I'll keep everyone up to date as we get more of these. phmass.org, you can kind of see the information we have. You can, of course, go to PHIAS's website to find out about their specific courses. But we are definitely going to see a demand for verifiers. So great opportunity to go through a training and get your certification and be set up to meet that demand. We have another course that we're helping to promote with the Studio for High Performance Design and Construction. This is for carpenters and contractors who are interested in learning high performance carpentry principles, things like putting insulation and air sealing materials into an assembly. And that's what this course is all about. It's a pod workshop where throughout a 6-week, one afternoon a week for 6 weeks, you and a team of other students work to construct mini pods using different types of high performance materials to make a high performance building pod. So the first course ran last fall, went very, very well, and now they're starting a kind of a new series. So this one starts May 4th and runs again every Thursday afternoon for 6 weeks. It is eligible for 100% reimbursement through the Commonwealth Grant Workforce Development Program. This is open to many companies to enroll in. Most companies will meet sort of these requirements. There's a few that if you're large, you might only get 50% reimbursement, but the fall course had, I believe everyone who went through this received the 100% reimbursement. through the fall course. So it's a really, really great opportunity for you to go through this, or if you, for all the contractors and GCs out here, send some of your carpenters through this course and learn some of these, high performance building principles on an actual assembly. The key thing is, if you want to be eligible for the reimbursement, you have to register by April 20th. So even though the course won't begin until the 4th of May, you have to do all the paperwork by April 20th to get the reimbursement. So I urge folks, jump on this if you have an opportunity. They're hoping to run another course later in the summer, but for now, this is the only one open for scheduling. So definitely take them up on this course. Now, a few news items. Boston just announced a large building green energy retrofits program. Those who have been attending our sessions kind of throughout the year and last year know that we've been really pushing for more deep energy retrofits and passive house retrofit funding through various means. So this is just the city of Boston, not statewide, but it's nice to see them offering this. And this is for affordable housing developments, low-income buildings. So all the affordable housing folks out there, I know many of you attend these sessions, pay attention to this. They're awarding the funds right now. You can apply. So really cool to see Boston, starting to do this. And we hope that there's going to be a larger statewide program to come in the future. I think we all hope that. Specialized opt-in code. This is something we've been talking about for quite a while. We had a whole session about it, our last several meetings. We are now starting to see more and more communities take this up at their town meetings or through their city council meetings, and more pass it. We're currently up to 7 communities now that have opted in. So the first 4, Brookline, Watertown, Somerville, and Cambridge, that will go into effect July 1st. And since then, we've had 3 new communities who have opted in: Newton, Lexington, and just as of last week, Boston. And it will go in effect to those communities on January 1st. And something kind of cool, the proposal in Boston came from Mayor Wu, and she did it at a press conference where she also announced that deep energy retrofit program I just mentioned. And in her remarks, she specifically called out some of the groups that advocated for this net zero opt-in code. And one of the groups she mentioned by name was PHMass, Massachusetts. And I want to extend my thank you to all the folks on this session who were part of that advocacy. There's a lot of folks out there, folks from our board, but also a lot of members who did things like going all the way back to the BBRS meetings, writing in letters and making comments to the DOER as they were drafting this proposal and this new code. And now working in your respective towns to get you to opt in. It's being recognized. Our work is being recognized. So it's great to see that. And thank you guys for all your work been doing that and helping implement this in communities. So transitioning now into sort of the meat and potatoes of our session tonight on non-residential homes. As we all know, the new code is an improved pathway pass house is an improved pathway in the new code, both in the stretch code and in the specialized opt-in code. We've been doing a lot of conversation, a lot of talking about the residential and multifamily project implications of this, specifically with the specialized code requiring multifamily projects over 12,000 square feet to be passive house. By the way, I don't know if folks out there know quite the implications of Boston doing this, but last year, I think they had, I've heard the number was around 45 or so multifamily projects go through the permitting process in the city. I mean, a small amount of those were passive house. But this means when it goes into effect in Boston in January, we're looking at 40-some new passive house projects, which is really exciting. But for this session tonight, the key takeaway is that it's not just residential projects we're talking about in the code. Passive house is an improved pathway for all building types. So whether you're a single-family residential building, a townhouse, a multifamily building, or one of the many numerous other building types out there, you can use passive house to meet code. So tonight, we want to highlight all the different types of buildings out there that are implicated by this. I mean, we're talking about schools and museums and hospitals and city halls and other municipal buildings and all different types of building types that can now use passive house to meet the energy code. So for those of you out there in different cities and towns considering the opt-in code and thinking about how this, how this impact this will have on residential projects, consider the commercial projects that will be able to take advantage of this and use passive house to move the code. So let's walk through what we're talking about here. Non-residential passive house. So again, passive house certification can be achieved by any building type of any size. as I mentioned, residential projects, townhouses, multifamily buildings, but all these other building types as well. The photo you're seeing here on the right is the Rocky Mountain Institute out in Colorado. You may have seen this building in other presentations. It's been sort of used as a highlight of both Passive House and as LEED and Net Zero and other building standards. They did a whole bunch of them in this project. A well they met as well. So a lot of different things they did in this building. At Passive House was certainly one of them. So it's a great, remarkable one. You may have seen projects on it, but it's certainly highlighted the various different types of buildings that can meet Passive House. So tonight, what we want to do is take a few moments, by a few moments, about 60 minutes, to talk about non-residential Passive House buildings. So we're going to show a few examples of different types of Passive House projects. Some of them will be very short examples, just kind of showing you a few photos and mentioning some facts about them. And then we'll have a couple of projects where we do a little bit of deeper dives into show a little bit more details. There's a few videos where the project teams are kind of speaking a little bit about them, so you can hear from their perspective. So we'll kind of go through different types of projects here tonight, and really hope to kind of show you the scale that Passive House can have, and the fact that these types of projects that you see listed here, commercial offices, stores, schools, municipal buildings, libraries, healthcare facilities, all of these are being done already. There's examples of all these projects. Oh, folks, just keep yourself on mute there. Thank you. All these different projects, there's great examples of already happening. So those are kind of the takeaways tonight and what we kind of want to highlight. Later sessions throughout the year, maybe we'll do some deeper dive case studies into one or two of these in particular, but really want to give you the highlights here tonight. So let me go the right way here. So here's our non-residential Passive House projects in Massachusetts. We got 4 of them. Well, 3 of them right now and 1 on the way. Down at the bottom corner, you got the Waring School up in Beverly, school built to the Passive House standard. You got a single-story office building in Newton, the Omni-Dealer's office. You got the Winthrop Square Center, of course, that we've all been hearing great things about, and now has people in it. It's occupied. Tremendous project, the largest square footage of certified Passive House office space in the world. And then the one in kind of the center of your screen at the top, just a conceptual image there, because that is still in development, but that will be a new office for the division of capital asset management out in Northborough. So these are the non-Passive House project, or non-residential Passive House projects in Massachusetts. So this is one of the reasons that us at PHMass probably haven't talked about commercial projects as much as we should. So we haven't had a whole lot of nearby examples to draw. We're really hoping that this is going to, increase here in the near future, especially with the pathways being open to these projects in the new code. So a lot of the stuff I'm going to show you tonight are branching out across, really across the world to show you what is being done and what can be done right here. So let's take a look at a few in kind of the greater New England area. We have an office building, a small office building there in New Haven, Connecticut. Right below that, you're seeing the Noba Retreat Center, right up in southern New Hampshire, about halfway between the Massachusetts border and the Maine border. Some of you have been in that building. We actually held a joint conference with Passive House Maine and Passive House Connecticut there about 4 years ago or so, and it's an amazing facility. They have a fireplace in there and lots of other kind of unique things they did, and we're still able to meet the Passive House standard. The building you're seeing then in the bottom right corner there, that's the Bowdoin, just a university building, a living and learning center in Maine. And above that is another school, lower school. This is a high school in Portland, Maine. So you're seeing sort of a variety of different buildings here in the area. So a couple schools and a couple other building types. So let's highlight kind of just a few numbers here. Got a couple slides to just talk about how non-residential projects compare to residential projects overall. So worldwide, this is FIAS and PHI projects combined. So this data right now is just showing you both of them combined. So about 15 to 15.5% of all certified Passive House projects are non-residential worldwide. If we bring that to just North America, we're down to 7.5% of projects. So you can see the big difference between looking at international, which I should mention is mostly Europe, though there are some projects in various Asian countries and a few other places, but this is mostly European countries that we're talking about for the gross number here, but about 15.5%. North America, honestly, in most of these projects, I was here in Canada, and one of them is actually in Mexico as well. So not a lot here in the US as of yet. Let's work on that together, all right? Here are the different building types we're talking about. So non-residential means a lot of different things. And I went back and forth between saying non-residential and commercial because, sometimes use them interchangeably, but not quite accurate because we're talking even more about, not just commercial buildings as well, lots of different municipal and government buildings and public buildings and different types. So here's the data. So again, this is a mixture of PHI and PHIAS, and you're seeing them kind of by category. So the largest, by far the largest number of non-residential buildings are school. And specifically small schools. In this case, small versus large is about 20,000 square feet. That's sort of where the cutoff is. So small schools are by far the largest number of non-residential projects. And just to clarify this, if we're talking, say, about a university residence hall, that's not factored into here. These are only classroom buildings and other types of buildings. These are not residence halls at all. Those are separate. So small school buildings are by far the large. Then we have small offices or commercial buildings. And then we go down to our large schools and our large offices. And then we get into government and public buildings. This is a variety of different building types. It might be a city hall, municipal building, a public library fits into this category. There's also a fire station that I'll show you an image of that fits into this category. So a variety of different type of, say, municipal and public buildings. And then we have hotels, which they are of. There weren't really enough of these to separate them into large or small, but most of these are smaller hotels. Recreation centers, so kind of different types of buildings there. We have some ones that are more gym focused. I have one example of a swimming pool facility that I'm going to show you a little later that met the standard that falls into the recreation center category. So again, different types of buildings there. Then we have supermarkets, grocery stores, healthcare buildings, so a variety of different types of healthcare facilities. Today, we're going to look at a hospital in Germany, and I'm also going to show you an animal hospital, a veterinary clinic that's being built right now in North Carolina. We have industrial buildings. These are probably different types there that kind of meet that category. And lastly, a few museums. So these are kind of the range of different types of projects that are non-residential passive house buildings. Now we're looking at the same data, but this is showing you North America versus international, or North America versus the world, as it says in the headline. But what we're seeing is, again, the vast majority of these are international projects, and we have a few that are here in the US. Question in the chat about PHIAS versus PHI. I don't have a graph that's breaking that down here, but I can tell you that on this screen, the red images that you're seeing, over 90% of those are PHIAS projects. The blue, which corresponds to the international, so non-North America, so buildings outside of the US and Canada, most of those are, those are pretty much all PHI projects. So you can, basically the red and blue here is sort of correlating, but some of that red are PHI projects. I hope that kind of answers the question. It's not an exact breakdown, but you can kind of use those colors to give you a rough idea. That's what we have here. So as you can see, there are a wide variety of projects around the world that are non-residential projects. And we have some here in North America and some in the US, but not as many as we've seen around the world. And part of that is simply because Passive House started in Europe much earlier than it did here in the US, and they were much quicker to adapt it to a wide variety of different building types. I think I talked about how the first Passive House kind of building that was done in Germany was a multifamily building. So they already went to multifamily versus single family right away. And very quickly they went into commercial and other types of building types. We've been a little slower to it here in the US. So all of us can work on changing that. So let's take a look at some very quick examples, and then we'll go into kind of some ones that we'll spend a little bit more time on. So I just got to move a few things around my screen so I can sort of see everybody. All right, so we got an office building in Germany. That's sort of a larger office building there. That one's probably around 12,000 or so square feet. Down below that, you have a fire station in Germany. So as of now, that's the only certified fire station that I know of, but it is a certified Passive House fire station. What you're seeing then on the other side of the screen is you have this sort of lab building up in British Columbia, and it's actually a wood innovation research lab for CLT and other types of lumber products. And below that, let's see. Oh, sorry, let me move some stuff out of my screen here. There is another office building in France. So just kind of showing you a few different building types. Again, as you remember from that chart, we had small schools as the largest, kind of around 150 or so of those worldwide, and then a few less than that were the small office buildings. So what you're seeing here on screen are an example of, to the left, kind of one that would be in that small office building category, and then the one on the right, the bottom corner, is one that is in the large office building category. Question in the chat about how the fire station got certified. So I don't know all the specifics of it. What I can tell you, those of you may be questioning it a little bit, they did carve out some space. So I know for sure they carved out some of the space down on where, if you look on the image, you can see the fire trucks in there. I believe that room right there, well, sorry, I shouldn't say that room, but I know there is some space that is carved out of the Pass House envelope, but the majority of the building is in it. So I think it helped by having being able to carve some out of it. And that's sort of a good thing to think about for those of you who are new to Passive House and new to thinking about in commercial types. Both PHS and PHI offer the ability to kind of carve out some spaces that might be most challenging to meet the standard and still be able to get the building certified as Passive House. This is something you would work with your Passive House consultant and designer on, and kind of they'll work with the corresponding certification agency. But so if you have a commercial project where you kind of have a certain part of that building, whatever reason why that you think is going to be really, really challenging, that's no reason to just not consider Passive House at all. You might be able to get some sort of exception to carve out that area if that's only a small part of the building. So now we're going to take a look at that swimming center. So this is a swimming athletic center. They have a few different, this is one pool. They have a few different pools in there, but this is a certified pool. So this uses 50% less thermal energy than a typical water park, so an equivalent size water park would use. I don't have a lot of details on it, but I know one of the challenges they had was actually just in water treatment itself. Large pool facilities like this have to do spend a lot of energy treating water. So one of the things they did is use sort of an innovative UV treatment system that cut down on the energy they spent treating water and kind of running it through their system. So that was sort of one method they used here. They also noted when they were developing this that the increased ventilation requirements that were part of Passive House and the higher quality ventilation systems that they were able to use, the energy recovery ventilators and so forth, helped them deal with the humidity issues that they tended to have in pools due to the evaporation of water. So they actually were able to kind of keep the humidity levels under better control as sort of a byproduct of having the greater ventilation systems that Passive House required. And we'll kind of go back to this just for one moment, because when we talk about kind of these sort of, I don't want to say unusual building types, but the ones that stand out, a swimming pool, they all have different unique challenges. In this one, high energy use from treating water was a very unique challenge. But they were able to figure it out and figure out how to deal with it and meet the Passive House standard. But when we look at a lot of these different types of commercial buildings, when we get outside of just schools and offices, we see a lot of cases where we, have these sort of interesting questions that projects have to figure out. But again, the PS and PHI are both going to work with you on kind of helping you to figure out how to solve those challenges. Here we have some, so we basically have like religious centers. We have a youth counseling center that's, I think, affiliated with the church in Germany. And then to the right, you're seeing actually a Buddhist temple in Japan. Both of these Passive House certified. So church facilities, perfectly capable of achieving the Passive House center or Passive House standard. Here we have a sports and cultural center in Sweden. This is a pretty large building. It is built with a mix of concrete, steel, and CLT lumber. But they have a wide variety of different sort of uses for this building. There's a theater, there's an exhibition hall, there's a cafe, an office, and a gymnasium, all of which is inside the Passive House envelope. And they also have an ice rink, or as they call it, an ice hall, a large ice hall, that is outside of the envelope. So that's sort of the one, I think, interesting caveat with this one is they weren't quite sure how to get, this was certified with PHI, and they were working with them to try to get the whole building certified. And they actually built the ice rink mostly to what they thought could meet the Passive House standard. And it just came down to the fact that at that point, PHI didn't really they couldn't figure out the right criteria for an ice rink. But one of the things that this project team noted is that the ice rink itself, even though it was outside of the official sort of Passive House envelope for certification, they utilized it in order to meet Passive House certification. So an ice rink has a lot of cooling that is needed, a lot of energy put into cooling. So they ended up using the waste heat from that as one of the heat sources for the rest of the building. In fact, they noted, I'm looking over to my side, sorry, to make sure I get this right. They provide that waste heat from the ice rink provides 70% of the required heating for heating and hot water. 70% of the heating and hot water heating comes from the waste heat from the ice rink, which is a pretty kind of innovative and cool way to make an athletic and cultural center like this meet the Passive House standard. The rest of the heat, the remaining 30% for the building, comes from geothermal heat pumps. Here we have another building type. This is a museum. So here's one in Germany. We have a few different museums that were out there. If you remember from that chart that I showed you, museums were at the bottom, but there was a significant amount of them that we could kind of pull them out from other building types and show one of their own. But museums, of course, also have their own sort of requirements. You might want to have very strict temperature control and humidity control to museums, which of course is something that I think the Passive House standard can really help with. So in many ways, Passive House is perfectly suited for a museum. Here, we have one in England where Passive House, this is incredible. This is an Imperial War Museum paper storage. So they're storing paper documents in here. They have over 14,000 linear meters of paper documents stored, which sounds like a lot to me. I'm not 100% sure. I'm not in the paper storage industry here, but that sounds like a lot. And it's critical to keep them, under the right humidity and heat controls. So Passive House is what they turned to build this incredible building, and they achieved. This is not incorrect. This is I'm not misspeaking here. A 0.033 air changes per hour. The record for air tightness in a Passive House building here. It may be in a non-Passive House building. I'm not quite sure, but an incredible project. No windows, but they hit it there. I believe their heating demand was about 2 kilowatts per square meter, so really, really low, but they were able to do it. And again, Passive House really helped them to kind of, especially with the ventilation and heating controls, to really maintain that indoor temperature and indoor humidity they wanted. Here's a cultural center for a First Nation community up in British Columbia. Another kind of unique aspect, the different building type that could hit it. And then, of course, in a very cold climate. Don't have much else to add about that. And this one, I don't have much else to add to other than saying I'm looking for volunteers to take a road trip out here. This is a cidery out in New York, 700 Hill Ciders. Hit the Passive House standard. You can see kind of just a photo of the inside. I mean, they have a restaurant, and you can go in there, have some cider. They have a bar, so and all that was under the Passive House envelope. A pretty exciting project there, and one that I'm looking forward to visit for a while here. So those are some quick ones. Now we're actually going to dive into a little bit of longer examples, and some of these are going to have some videos so you can hear from the project teams and not just me. But this is a hospital. This is a certified Passive House hospital in Germany. Here's the details about it. You can see one of the patient rooms here. So the pretty large building, 61,000 square meters. You can see the team. Ask questions if you have about some of the details in the chat room, but these are the details about it. I mean, things to notice: the air tightness, 0.13 HH50. I mean, incredible air tightness. And I think one of the things that stood out to me as I looked at a wide variety of non-residential projects is the air tightness. A lot of them were incredibly airtight, blowing the 0.6 HH50 out of the water. It's really amazing to see that. But here's the hospital there. But for those of you familiar with hospitals or healthcare, it's one of the building types that's challenging, and not because of the kind of general reasons Passive House projects might be challenging, but because of a large amount of electricity demand for various equipment, mechanical equipment, and various medical equipment that they have to use. So here's just showing you. So this is comparing the final energy model from Passive House, what they met, versus the MEV, which is just that is a German energy standard. So basically, you could think of that as comparing the stretch code to passive house for Germany. If they didn't go passive house, what they would have done is met this NED standard. And you can kind of see how it's broken out here. So I'll just kind of let you look over the data a little bit, ask some questions if you have it. You'll see some of the biggest areas they reduce. Obviously, heating dropped dramatically. Drinking water didn't drop as much. In fact, it's kind of interesting that hot water demand went up a little bit, it looks like, in the passive house model. But all those other uses, all those various mechanical equipment, dropped dramatically. So simply by using more efficient equipment, they were able to dramatically reduce the electricity usage in the building. And that's one of the, I think, takeaways that I had from looking at all these different project types is a lot of the challenges and presumed challenges in electricity use in commercial projects are things that should be solved anyway, simply by using more efficient equipment. And it's simply that a lot of our old office buildings haven't done that yet and updated that efficient equipment. If they were building a new building, they probably would anyway. But they certainly did here. The other challenge in a project like this is waste heat. They need a lot of heat for hot water. They use hot water a lot. They also use steam. They also use a lot of heat to generate some pressurized air. I mean, there's lots of different uses of heat, but they produce a lot of waste heat. So this is an example of how they're reusing that waste heat. Sorry for the blurry image here. This is from a presentation that they provided, but waste heat. So in general, if you have 100 watts of waste heat being produced, the blue box there is their heat recovery ventilator that recovers 80% of that waste heat, something I think we're familiar with it. But what they were able to do with that is 64 watts of that 80. So from 100 watts, they recover 80% of it. So we're at 80 watts. 64 of that went right back into the building as a heat source. The other 16 was sort of waste heat, went into areas that were already being heated and they didn't need. So it's just kind of more heat. But 64, they were able to basically recover 64% of the heat was able to go directly into heated spaces and be a source of makeup heat. They also calculated the energy it took, the increased energy use of running this ventilation system in order to do that was calculated to be 26 watts. So the question that I have gotten at times, and many folks here have had, is what's the trade-off? Yes, you can recover some of that heat energy, but at the same time, you're using a lot more energy for that process. Well, you can see it's definitely a positive trade-off for them, and one of the key ways they were able to achieve passive house. But let's actually watch a video of it here. You may recognize some folks in this video.
Diese Besuchergruppe aus Boston bricht zu einer besonderen Baustelle auf. In Frankfurt entsteht gerade das weltweit erste Krankenhaus im Passivhausstandard.
Apologies there, folks. I'll go ahead.
Diese Besuchergruppe aus Boston bricht zu einer besonderen Baustelle auf. In Frankfurt entsteht gerade das weltweit erste Krankenhaus im Passivhausstandard. Wie viele internationale Besuchergruppen wollen sich auch die Gäste aus den USA dieses bisher einmalige Großprojekt aus der Nähe anschauen. Sie selbst planen, in Boston ein Hochhaus mit Wohnungen und Büros im Passivhausstandard zu errichten.
Wir als Bauherr müssen natürlich
Carsten Valentin von der Zentralen Errichtungsgesellschaft ist zuständig für die Umsetzung des Pilotprojekts im Passivhausstandard. Über 143 Meter lang ist das neue Gebäude in Höchst, 23 Meter hoch und nach Fertigstellung wird es über 660 Betten für die Patienten haben. Valentin erläutert bei der Führung auch die Besonderheiten beim Bau eines äußerst energieeffizienten Krankenhauses.
Ein Krankenhaus liegt im Gesamtverbrauch nicht wie bei einem Wohngebäude in den statischen Verbrauch, sondern 80% sind nutzungsorientiert. Das heißt, durch die Medizingerätetechnik, durch die medizinische Nutzung wird hier der Hauptverbrauch generiert. Und deswegen ist es besonders wichtig, bei dem Krankenhaus sich sehr genau anzuschauen, wo wird welche Energie an welcher Tageszeit und in welcher Form verbraucht. Damit bin ich in der Lage, die Energie intelligent zu verteilen und maximal effizient auch dann zu erzeugen.
Das Klinikum Frankfurt-Höchst der Klinik abgerissen. Bevor hier am neuen Standort in der Windtorstraße der erste Bagger anrollen konnte, waren sehr viele Vorbereitungen nötig. Seit den ersten Planungen begleitet Oliver K. vom Passivhaus-Institut in Darmstadt den Klinikneubau. Zusammen mit Kollegen hat er
Sorry, folks, it appears a few technical issues there. I'm going to try one more time to just make
dieses
it go.
Pilotprojekt eine Grundlagenstudie erarbeitet. Darin wird untersucht, wie der Passivhausstandard speziell in Krankenhäusern umgesetzt werden kann.
Durch den 24-Stunden-Betrieb in Krankenhäusern und aufgrund der vielen Energieanwendungen in Krankenhäusern, wie zum Beispiel Sterilisation, Intensivstation, gehören die Krankenhäuser ja zu den Spitzenverbrauchern unter den Gebäuden. Ein weiterer Aspekt, der eben zu höheren Energieverbrauchen in Krankenhäusern führt, ist der, dass die Innentemperaturen höher liegen. Und dann ist es natürlich gerade interessant, hier Energieeffizienzmaßnahmen anzuwenden.
Dass es sich gerade bei einem Krankenhaus mit Tag- und Nachtbetrieb lohnt, den Energiebedarf unter die Lupe zu nehmen, das wird auch hier in der Notaufnahme des Höchster Klinikums deutlich. In diesem Schockraum mit vielen medizinischen Geräten werden akut lebensgefährdete Patienten behandelt. Einige Stockwerke höher ein medizinisches Großgerät. Bei der digitalen Subtraktionsangiographie werden Blutgefäße des Gehirns und des Rückenmarks detailliert dargestellt. Das Gerät benötigt auch Energie für die Kühlung. Ansonsten überhitzt die mehrere 100.000 € teure Maschine innerhalb kürzester Zeit. Neben der 24-Stunden-Beleuchtung und der Intensivstation zählt im Klinikum Frankfurt Höchst auch das Elektrophysiologielabor zu den Spitzenverbrauchern an Energie. Hier werden mit modernster Technik Herzrhythmusstörungen behandelt. Allein für einen Patienten laufen die zahlreichen Geräte und Monitore rund 2 Stunden lang.
Wir haben tatsächlich versucht, uns alle Prozesse, alle medizinischen, alle technischen Geräte im Krankenhaus vorzunehmen hier und zu untersuchen, also inwieweit durch Verbesserung allein der Effizienz man hier den Energiebedarf im Krankenhaus verringern kann.
Diese Energiebilanzierung für den Neubau in Höchst war eine gewaltige Aufgabe. Das bestätigt auch Carsten Valentin. Er hat bereits in Bad Homburg den Neubau der Hochtaunus-Kliniken technisch verantwortet.
Die Thermosimulation war eine Herkulesaufgabe für alle Beteiligten. Zum einen natürlich für die Planer, es war Neuland, aber auch für die Nutzer, für die Mediziner, das Verständnis zu haben, sich die Zeit zu nehmen, aber auch sich mit ihrem Prozess zu befassen und mit dem Prozess auch real umzugehen. Das heißt, ohne eine gesteigerte Reserve oder ohne Angstzuschlag die Informationen preiszugeben.
Auch die Hersteller der medizinischen Großgeräte mussten davon überzeugt werden, von den Standardwerten abzurücken und für die thermische Simulation mit reellen Werten zu arbeiten. Wie wichtig die genaue Bilanzierung des Energiebedarfs ist, das verdeutlicht wiederum die Grundlagenstudie des Passivhaus-Instituts. Wird nach konventionellen Verfahren bilanziert, dann entgeht den Planern ein großer Teil des tatsächlichen Energiebedarfs im Krankenhaus.
Wir beginnen mal hier. Rot ist Heizung. Trinkwasser ist dieses Tortenstück, dann Lüftung, dann Bereich Kühlung und Beleuchtung. Und das wäre der Bereich, der bei konventionellen Energiebilanzverfahren betrachtet wird. Das heißt, rund die Hälfte des Gesamtenergiebedarfs des Krankenhauses haben wir gar nicht im Blick.
Weder der Energiebedarf für EDV und Verpflegungsküche noch der für Sterilgutversorgung, Magnetresonanztomographie oder sonstige Anwendungen wird bei bisher üblichen Berechnungsmethoden berücksichtigt. Damit entgeht den Planern natürlich gleichzeitig auch ein großer Teil des Kühlbedarfs für die Geräte. Die Studie des Passivhaus-Instituts kommt nicht nur dem Krankenhaus in Frankfurt Höchst zugute. Insgesamt gibt es in Deutschland über 2000 Krankenhäuser. Viele der Gebäude sind sanierungsbedürftig. Wenn saniert oder neu gebaut wird, dann energieeffizient und zugeschnitten auf die Bedürfnisse einer Klinik, so die Überlegung. Auch die Patienten werden von dem äußerst energieeffizienten Gebäude profitieren. Sie erwartet unter anderem eine verbesserte Raumluft in den Krankenzimmern, die auch auf die Lüftungsanlage zurückgeht. Das erfahren auch diese Bauexperten aus China bei ihrem Besuch in Frankfurt. Sie sind in Deutschland, um sich das Pilotprojekt in Höchst anzuschauen. Sehr gerne führt Carsten Valentin die Besucher auch auf den Hubschrauberlandeplatz. Hier auf dem Dach des Krankenhauses genießt auch die Gruppe aus Boston den Sonnenschein. Und das Gefühl, mit dem weltweit ersten Passivhaus-Krankenhaus Zeuge eines zukunftsweisenden Projekts zu sein.
pretty efficient, and there are no CO2 emissions.
All right. Well, thanks for sitting through that, and I hope you were able to read the subtitles all right there. When this gets posted, the whole recording of this, I'll try to link to some of these videos as well, in case the subtitles don't come through too clearly on the image. So that's the hospital. We can talk more about it depending on what the questions you guys have in the discussion, but a really cool building type to see meet the passive house standard. And well, I'm going to move on, and maybe we'll address some stuff in the discussion if it comes up more about that. But I'm going to move on to a project here, a different building type. This is a Subaru dealership up in Alberta. The first, and so far, as far as I know, the only car dealership to meet the passive house standard. So here's an image of the inside of it, the showroom, and you can see information over on the left on folks that worked on it. But again, look at that air tightness, 0.2 ACA50. The incredible air tightness here is always kind of blew me out of the water here with these different projects. That's ventilation and heating. You can see some information there on what they use. They did use the sand and CO2 heat pump, which is something that's come up in some of our sessions here and there, and I know is being used in a couple of Boston projects now. A newer form of an all-electric all-electric hot water source, but a good example of being used in a non-residential application right here at this car dealership. This is another video. This one's shorter, only a minute or two here. It gives you a little bit of background on why this project went to achieve passive house and some of the details on how they did it in a very quick way.
Hi, I'm David Dodge. Welcome to Green Energy Futures. We've seen some amazing super energy efficient buildings on Green Energy Futures, including living buildings and net zero churches, homes, and even department stores. But we've never heard of anyone doing what the Scott Subaru car dealership in Red Deer is doing.
Hi, I'm Garrett Scott. I'm the dealer principal of Scott Subaru in Red Deer. And we are almost completed our construction of the world's first passive house car dealership.
Scott said they were inspired to do something special when they visited the Subaru plant in Indiana.
Subaru America has a zero waste plant. And the plant is also sitting on kind of like a wildlife nature preserve as well. They've got incredible kind of wetland and green spaces around it. And the zero waste is pretty unique when you consider manufacturing. You're always wasting a little bit, you would think.
Inspired by the zero waste idea, Scott came back to Red Deer and talked to Cover Architects and came up with the idea of building the first car dealership built to the passive house standard.
We wanted to be able to have the ultimate calling card and have something that was so unique, but also represent some of our values. Why waste if we don't have to? Why build something that's just ho-hum that everybody else has done before? And if you're going to be in one spot for 50 years or want to be here for 50 years more, let's build a legacy project that means something today as much as it would 20 years from now.
There are many reasons why they undertook the project.
We're talking about eliminating 80% of our heating and cooling costs almost. And that's the reason we did it. That's cool. That's really quite exciting.
But it's about more than saving money.
Being as efficient as it is from an energy standpoint motivates us to take our business and follow a similar trend where we try and make the most efficient process for our customers from a purchase standpoint, from a repair standpoint, but also then correlate that into our staff. Passive house buildings are considered much more livable and much more enjoyable than your standard commercial building is.
So how do you take a car showroom with floor-to-ceiling windows to passive house standard?
So passive house is essentially an unbreakable blanket around the building that keeps it insulated from the environment outside. And that goes with the walls, the windows, the doors, and also the foundation, the flooring. You build exterior walls that are getting close to 20 to 22 inches thick. You've got 4 layers of different types of insulation, types of material, impenetrable barriers.
All of this adds up to a car dealership that uses 80% less energy and doesn't have a conventional furnace.
There is heat recovery units and then super efficient air source heat pumps. And these air source heat pumps, they can be 200% more efficient than a furnace. And with that, you get those incredibly low consumption numbers. And they're rated now to be available in Alberta for temperatures up to -30. We're very confident that this will get done. But the big issue with this building isn't necessarily heating it. The envelope's keeping the heat in, it's cooling it. And these heat pumps also work in the inverse fashion, and they cool the building too.
Garrett's grandfather, Kip Scott, opened the family's first car dealership in Red Deer 50 years ago. Garrett says this is a legacy project that he hopes will still be cool 20 years from now.
This building will also garner some more exposure than a traditional new dealership would. And that's also one of the big motivators in doing this is to achieve the goals we have as a Subaru dealer, we need to be extremely unique. This helps us get there.
Thanks for listening. Learn more at Green Energy.
All right. Should thank Green Energy Futures for that out of Canada for that video, and PHMass Institute recorded the video that we watched about the Frankfurt Hospital. But kind of cool to hear, him emphasize some of the things that we talk about in residential projects. I mean, the enormous amount of energy savings, and that translates to utility savings, the longer lasting construction, a lot of these, and just simply being sort of a standout environmental project, and applying those kind of same ideas to a commercial spot here. And I think the 80% savings on heating and cooling is certainly something that I think most of us know commercial businesses would jump all over if they can save 80% of those costs. So a really good highlight of how the same principles apply to a commercial building here in Canada. So we're going to move on. This is a Warren Woods fuel station. This is a laboratory building in Michigan. We don't have a whole lot of examples of labs in different types. I'm going to show you two. This is a small lab here in the US and Michigan, and then right after this we'll show a little bit of a large lab in the UK. But this one, so this is actually part of the University of Chicago, but it's sort of a separate research facility that was built in southern Michigan. So here you can see the inside of it there, and some details about it. 0.48 ACH50 for the air tightness, which again, much lower than 0.6, but actually the highest, I think, of at least of the projects I've shown you in detail. But again, amazing to see what they're able to achieve. So there you go. This is this research station. I think it supports about 12 people who stay there on extended stays. So it has some residence areas and some research facilities and some living space. It also accommodates up to 25 research students there for a short period who aren't staying. Here you're seeing the main laboratory facility. So this is an ecological research station. So you can see the different types of lab space challenges they have. They have an incubator, they have centrifuges, they have some plant growth chambers and DNA extraction tools. And just like with a hospital, one of the biggest challenges for them was the two biggest challenges was the electricity that this equipment uses, and the waste heat that it produces. So those were two things where they had to focus on reducing the energy demand from this equipment by using more efficient equipment, and at the same time figuring out ways to use the waste heat. So this is just kind of showing the layout of it. But you see that lab space highlighted. That's the image I was just showing you before. That's where that picture is. So the internal heat gains from this were 8 watts per square meter. So that's all the equipment. The building total was 11.5. So just so you can kind of think of the ratio of heat gains coming from the equipment in that lab to just the building overall. Enormous percentage of heat gains were from that laboratory equipment. With all the heat gains accounted for, the space heating demand was only 2 kilowatts per square meter versus a target at that time for PHI of 15 is what they were shooting for. So space heating was virtually nothing for them. Now they did have to work with PHI, and this is another example of how you can work with the certification agencies. The PHI agreed to limit that 8 watts per square meter to 5.5. And the reason for that is they sort of went back and forth on how to predict future heating or future waste heat, future internal heat gains. And the idea was they didn't really have in their modeling good ways to predict that, and they settled on 5.5 as something they could plan for. And they also placed a heat pump hot water heater, so the source of hot water for the building in that lab space, so they can utilize some of that waste heat as sources for heat pump hot water. So that's this building here. I'm going to show you now another building. This is the University of Bradford out of the UK. This is one of their STEM buildings, and a larger laboratory here. And this one I am going to show you another video of this. This is the shortest video of the three that I'm going to show you, the final and shortest. But I think it's interesting to hear directly from the teams as much as you can here.
It was quite a rundown estate. I think the university realised that to regenerate, we decided 10 years ago or so to regenerate in a sustainable fashion. And I think it's fair to say the university is now known for its sustainable construction.
The brief was to create a flexible learning environment for STEM, science, technology, engineering and maths.
It was an incredibly tight budget, you know, $1.5 million to build a full university science lab. It was quite challenging on normal building regs, so we put extra pressure on the team to say, well, actually, we want Passive House.
One of the biggest initial challenges from a design perspective was trying to integrate BREEAM Outstanding and the Passive House, because they don't always blend that well together.
The nature of it being a laboratory, of course, has a lot of additional equipment, so the primary energy demand was quite a big consideration early doors.
But also then to create a design that actually sat within the landscape as well. So it's not a square box, as a lot of Passive House projects can be, but we've tried to create a bit of flair and design and imagination.
Because of the lack of passive solar benefit that we were getting in terms of energy, we therefore had to increase the building fabric and the air tightness levels, perhaps sort of 20–30% over what you'd normally do for a Passive House building.
The construction was largely off-site fabrication. We only had 4 skips to waste during the whole build, which is fabulous, really.
So there was a lot of time spent on site trying to get the details right to achieve that Passive House standard.
Yeah, it's a very nice building to work in. The comfort levels are quite nice.
Even when we've got all of the machines on in the lab, we still don't really see any fluctuations of heat, which is a big problem in normal chemistry labs.
So yeah, short video there. I really like that kind of last point that was highlighted of the comfort that this building has. That last remark about even when all the equipment's running, they don't see a change in the indoor temperature was pretty incredible. But highlighting that, especially for these type of spaces, I mean, not just laboratories, but all types of school buildings and office buildings where people are working and spending, 8 hours a day, comfort is incredibly important. And I think should not be an overlooked reason on why these type of buildings should achieve Passive House. It's not all about reducing energy. Increasing the comfort of these buildings goes an enormous way towards increasing the comfort of people. And as we've seen in other studies, their own cognitive performance as well. So pretty cool there. All right, a couple more projects to take a look at here. We'll open it up to discussion. I'm sure there's lots of things to talk about with different types of projects, but this is a school, and we're coming back closer to home here now. This is in Maine. This is a high school. Got a couple different projects or a couple different photos of it here. 10,000 square feet. Air tightness, again, incredible air tightness. Well, this one's CFM, but still that's a pretty low mark. Good project there. Really, comfortable and nice school, but you can kind of see some of the remarks, some of the equipment they used here. I'm going to actually just go ahead on a couple of things, and I want to show this, I think, a better way. So here we go. So what you're seeing is just kind of the red line is marking, their air barrier, their red line test, if you will. And you'll notice that they're kind of calling out the north wall insulation and then the other wall at 2 different levels. And so for the south, east, and west walls, they did one type of assembly, and then for the north wall, they did actually a different type of assembly. So they kind of integrated 2 different assembly types into the same project. And this one on the left kind of showing you some of those details about what they used on some of those walls. And I can answer some questions about that later, or you can have this information when the presentation is available. Here's it going up right now. You can kind of get an image of it. Going up when it is finished. So another example of different types of projects, as we saw in that chart, schools are the largest type of non-residential project. And I think for a lot of municipalities out there that are building new schools, renovating existing ones are always something that they're thinking about doing. And also the enormous amount of private schools in the area who are looking at building new buildings. Passive House is an excellent way to do that, an excellent resource, a great way for schools. And again, that cognitive performance that was highlighted in that lab building is so critical in our schools, especially in our schools with younger kids. Here's, look at this building. This is an incredible place. I want to almost go back to school just to go there, but not quite. All right, so last building type we're going to look at, this is that animal hospital, large veterinarian clinic. This isn't quite the same as the Frankfurt hospital. This is just for animals, but another type of medical facility we can't forget about. This is going up right now. It's under construction, so I'm not going to show you too much. We just want to highlight different building types to show you what's possible. Here's it going up right now. Kind of see some images of it recently. There it is on the outside. So just a lot of building types, a lot of different different things that can achieve passive house. This was also going for a 193 kilowatt solar system on the roof, which is already installed. And this is in North Carolina. I mean, well, we'll end there talking about that project. So a lot of different building types, and this one here is unique. It's a museum or exhibition hall, as it's known. It is in China, and it is an exhibition hall to sustainable building practices. That is what this building was designed to show off. And they are a certified passive house project. You can see some of the details, 0.2 ACH 50 here for this. We're looking right now at an image, all that glass is on the south side of the wall. And a huge source of heat for this building, of their heating demand, came from solar heat gain. It was an enormous part of their calculations. So now you're seeing a little bit of the outside of it, or sorry, of just the, a sketch of it. So again, you're seeing that glass face on the on the left side of your screen is the south side of the building. A large portion of the building is actually kind of underground there a little bit on the north side. And we'll go ahead here, another image. So this is sort of how they plan for ventilation and heating gains from the sun. So on the left, you're seeing their sort of ventilation approaches. So the top image on the left, you can see there is their energy recovery ventilator on the lower left of the building, and how it's sort of ducted into the different areas. So we all think about, and those of us talk about residential projects and ventilation. I think it's become kind of standard that we take air out, exhaust it out of kitchens and bathrooms and put it into living spaces. Well, when you get into different types of buildings, we have to figure out different places to take that air out and put it into. They're not all the same. So this is a place that actually designed it with ventilation in mind. So you can see the blue box there's sort of in the center around where the stairs are. That's what's putting out the air. That's the supply air. And then they're exhausting it primarily from the ceiling, from the two high points of the roof. They're sort of letting natural ventilation, encouraging natural ventilation and heat rise in the building. In the summer, you can see the one on the bottom, they're actually relying a lot on just having windows open in order to provide natural cooling through both sort of the natural flow through the building and through the skylight that will be open in the summer. Over on the right, you're seeing their sort of heat gain and their shading mechanisms for avoiding heat gain in the summer. They also have a green roof, which is one of the methods they avoid too much heat gain in the summer as well. Let me see here. Oh, I'm going to go back because I do have one more thing to say about this. So the sun shading system, it's hard to see. I don't have an image of it, but they actually have a tracker. So it tracks the sun, like some solar panel sun tracker systems do. Their shading mechanisms do it automatically as well and sort of adjust throughout the day to help keep the sun, help keep the building from overheating. But it's just, I think, just a really cool example of using solar heat gain in, well, kind of an extreme method, but they did it, and it's apparently a very comfortable building, not only passive house. So there we are. Summary: passive house certification can be achieved by any building, any size, any function. And right here in Massachusetts is now a method that's now an approved pathway in the code. And we're hoping that more building types will choose it. And we want to be a resource to help you guys do it. So those of you who are in different municipalities considering the code or looking at it, this can be any building type. So that's the presentation for today. We're now going to open it up to questions, discussion. There were a few in here. But go ahead, open it up. What do you guys want to know? You can raise your hand as well. Use the raise hand feature. Any questions out there?
Can you hear me?
I can hear you.
Yeah. So I think it's a great presentation. It really opens it up to show us what is possible with Passive House. I think it raises some other things that would be interesting to find out. My understanding is that across Europe, the PHI standard has been adopted with variations in each country. So Sweden and Brussels, et cetera, have put together their own passive house standard. And I don't think it's critical to understand, they're all aiming at the same thing, but I think it would be very interesting maybe if we could ever get a comparison of those to see what kind of variations are being introduced in what countries and why. That would be interesting. The other takeaway I have here is that schools in Massachusetts are a primary target for passive house. I'm aware of several schools in Cambridge and other outlying areas which are being designed to net zero, but not to passive house. And I think that's interesting. It seems to me that passive house should be promoted for school production, and we ought to try to get to the state board that administers the school production financing.
Yeah, I completely agree. I think schools, especially when you think of the layout of schools, schools tend not to be, large towers. They tend to be kind of spread out more horizontally, which gives them lots of roof space, which makes them good targets for net zero because they just have a lot of space to set solar panels on. And as we talked about, and as a big focus has been on net zero over energy demand reductions, that tends to be the result. You throw solar panels on something and make it net zero. And the more and more we and others are getting the message that, well, we've had the message for a while, but more and more folks are getting energy reduction first, lowering demand before renewables. That's where passive house comes in. It's not just a matter of putting all the solar on there because you can. You want to reduce that demand first. And as you said, schools are an amazing target for it. And I think if we can figure out ways, and you guys on this presentation, to highlight things like indoor air quality and comfort, that's an enormous talking point for schools. I mean, it's an enormous benefit for them to have more comfortable and healthy indoor space for their students that passive house can provide. And net zero by itself doesn't provide that at all. We have a question. Madeline, you have your hand up?
Hi, yeah, can you hear me?
Yes, I can.
Hi. So I guess well, thank you first of all for the presentation. It's great to see so many different types of buildings, especially high ventilation buildings. So my question is a little bit more related to specifically Passive House US. It seems like the majority of the strides in the world of commercial has really been PHI, abroad and in the US, like Winthrop Center. Do you anticipate, or do you think that there is a move within PHMass to have a commercial specific standard that's maybe a variation of or more tailored to commercial buildings that is not necessarily built off of the multifamily or the single family residential standards that currently exist? One of the reasons I'm asking this is we're doing a commercial project in Cambridge, Massachusetts, and we're having a lot of issues with kind of some of the interpretations of Energy Star and other subset standards that are part of the US-based version that I don't believe are part of the international PHI version. And I'm wondering if there's a move towards that within the Passive House community to have a more specific standard for commercial that's not necessarily a variation of the multifamily and single family that we kind of are in right now.
Yeah, I think that's an excellent question, and I unfortunately don't know of any development within PHMass to create a separate standard. So I'll open it up if anybody else on here has other information or has heard folks from PHMass talk about it. Please do. But you did kind of bring up something I wanted to kind of get at, the difference between, I showed all the numbers, about the international versus North America. Here is looking at PHMass versus PHI, just so you can get an idea of the different types of buildings. So there are, a good amount of PHMass projects, well, a good amount, not compared to PHI, of course. But I should highlight, when we're talking about projects overall, the majority of passive house projects in the world are PHI projects, simply because PHI has been around longer. It started a good decade before Passive House US did, and it certifies projects all over the world. So there's naturally going to be a much larger number of PHI. And then secondly, we here in the US, for whatever reason, have simply been slow to adopt commercial passive house projects and non-residential projects. I mean, to be honest, we were kind of slow to adopt non-single family residential passive house projects as well. So it's really no shock to me to look at this and kind of see. There are, just to be clear, there are examples from PHIUS of these different building types. You can see pretty much all of them have some PHIUS examples. So it's not strictly PHI that we're talking about here. But if anybody has a good answer to that question, is there any kind of, thinking of within PHIUS to kind of create a separate standard? I do know that when you do say your energy calculations and your modeling, they do have, whether you're a residential project or commercial project, they do account for that, and your numbers are, your targets are going to look a little different, but it's still basically the same thing. Hank, is your hand up again to ask them?
Yes, it is. Yeah, I would say that this is in part our own making. We started by getting the Mass Save Passive House incentive in place, and that was an incentive that was built around residential. We also went to DHCD and got them to add bonus points into their scoring system for affordable housing for passive house. The combination of those two things has caused an explosion of passive house multifamily residential in the state. We've gone from less than 100 units 4 years ago to 10,000 units in the queue. So our policy stuff is confusing. You got to be clear what's going to happen. Collateral damage is something you can encounter. And one of them is that we have put an emphasis on housing in an artificial way. I believe that PHIUS is ready to do commercial buildings, but in Massachusetts, we've incentivized housing to the point where we said, you know what, we need to do a presentation like we did tonight to show that much more is possible.
Yeah, and along those lines, I think something that we're coming up against is in the commercial world of trying to implement passive house, which, as you just mentioned, Hank, has been amazing in the multifamily and single family sectors. It's really just absolutely taken off, and it's fantastic to see. But some of the subset, zero energy ready homes from DUER and Energy Star are really geared towards those residential standards. And part of my kind of overarching thought posed to the group about kind of a separated or a more specific kind of narrowing down of what we're actually applying commercially, or maybe it's multiple different pathways if it's a school or a government building, or just tailoring it a bit more to kind of release ourselves from the complexity of what applies when we're looking at Energy Star and DOER zero energy homes. And if there's a move to that, or if that is something that, would help the wider spread adoption of PHIUS in the commercial sector, or make it easier with this stretch code transition.
Hank, you're talking, but you're on mute.
I would like to add, I think that we might have an opportunity to go back to the to Mass Save and advocate for an equivalent program in the commercial side for passive house. They have many incentives built in for energy conservation on the commercial side, but when we started, we didn't focus on that. We focused on housing only. And I think it might make sense for us to be going back to the EEAC and pushing for them to add in a specific passive house incentive on the commercial side.
Richard, you have your hand up. You can go ahead and unmute.
I was just wondering if there's going to be any link for continuing education credits.
Oh, good question. There are not AIA credits for tonight's session. Sorry, I saw you in the chat. It looks like you were looking for those, so I apologize, but there are not AI credits tonight. Luke, you have your hand up?
Sure. I just wanted to note that MassSave does include in the commercial new construction and major renovations incentives that exist currently, 3 paths for buildings that do include a zero net energy path. None of them specifically ask for or require passive house, so passive house is not listed among them, but the incentives certainly can be more easily achieved through passive house. And certainly, as has been brought up here before, passive house as the path to zero is a strong argument. And so while the incentives, again, aren't specifically calling out passive house, it is certainly a way to achieve the highest incentives available.
A great point. And you kind of brought up that past messaging of, when net zero is in the conversation, you should be thinking of passive house and passive house strategies as your method to get there. Maya, you have your hand up?
Hi, just following up on that. I've been doing some research for my my firm on incentives lately, and I did come across one incentive under the residential new home construction program, but it's only for residential in Massachusetts, and there is passive house incentives available for multi-family residential above 5 stories.
If I may
multi-family.
that.
Yeah, I can put in the link on the chat or something.
And if I can speak to that as well, for the single family to 4 units, yes, again, passive house is not specifically called out as a incentivized pathway. However, passive house does still enable achieving the highest levels of the incentives for all electric, for instance, in the 1 to 4 family incentives.
Absolutely.
Yeah. And something, if it wasn't clear, I just want to emphasize that all the numbers of non-residential projects we've been talking about tonight are not counting mixed use residential buildings. So we do have, even in Massachusetts, we have multifamily projects that have maybe a commercial space on the bottom floor. Those are not counted as non-residential projects for this analysis. Hank, is your hand still up?
Yeah, Luke, do you think it would be worthwhile to try to lobby EEAC MassSave to specifically include passive house in the commercial side?
I do think, well, I think the code and the opt-ins are going to be one part of that. I don't know how, I mean, certainly the more pressure there is generally to adopt passive house, the more all of the players will participate with passive house. I don't know if EEAC and I honestly don't know how that would play out, other than that, yes, if it were a requirement in the 3-year plan, then that would certainly be something that would then be brought up as a part of the process in the MassSave responses to that.
Yeah.
I think that would be, yeah, I think that would be really great. In looking at the kind of deep dive into the codes, into the stretch code, it really seems like what we're starting to see in our office and in the chatter is that small scale commercial is really looking at Passive House because the prescriptive code is going to be very, very challenging to meet with the new thermal bridging derating that's happening. And so a smaller scale commercial building, which there's a great number of examples in here. I think you're probably flashing through to try and find them. Yeah, the small scale commercial, small buildings there, that group there is a great target for more increased incentives into getting FIAS, especially because it's just going to be that much harder to meet prescriptive requirements. And the package of Passive House is very appealing instead of the laborious backstop calculations and all the derating that you have to do now to meet the prescriptive. And I don't think that that group is as well supported incentive-wise as the residential sides are. And it typically tends to be a more, a smaller building development might be being done by, a smaller entity with not as deep pockets as maybe a much larger scale commercial development. They might be happening in, not necessarily like downtown areas, but in more, neighborhood areas or areas that don't have as much, attention for development. I think it's a really crucial type of commercial development that needs financial support to meet the new code mandates, especially in the Passive House world.
Yeah, thank you. And I brought this up to kind of go along with what you're saying and to kind of highlight, as we know, our Passive House is an alternative here in the code for these commercial buildings, both in the stretch code and in the opt-in code. But highlighting that, number 3, which would be in this case, are the small commercial buildings that have that prescriptive requirement option. And if there can be incentives there that encourage Passive House, I think that's what you're getting at.
Yeah, exactly.
And if we kind of target, maybe that's an area to target our advocacy.
Yeah, they're typically going to be less well funded than the commercial high ventilation buildings in this area are going to be mostly your lab buildings done by, pretty deep pocket organizations, or very large scale commercial that is also going to be potentially better funded. The small commercial buildings, the prescriptive requirements are really tough. And they're a lot more intense to document than they were previously. And a lot of people are starting to look at a Passive House as a really viable option, but the incentives aren't there the way they are in residential.
No, that makes a lot of sense. And if you think through the various building types, that might, as you point out, be the area where they need the most financial incentives to be able to do this. They don't have as deep of a budget as maybe some of the larger projects do. Do you have any other questions out there? I haven't seen anything else come up in the chat room, but please, folks, raise your hand if you want to even make a comment or ask a question about this topic. Anything else out there?
I'll fill in for a moment. I think I think that's a great suggestion from Madeline. I do think that Passive House incentives versus the prescriptive code requirements could be a very good pathway and one that should be promoted. Last comment is, I was curious, I don't know whether you know about this, Aaron, but the Warren Woods 3 Oaks, Michigan project was shown as being a GoLogic project.
That's correct. Yeah, so I didn't highlight that, but yeah, those are our friends to the north in Maine, and that was one of the projects they worked on.
Right. So I'm just, as a aside between you and I guess I think we ought to think about getting GoLogic to present that project, because they're a modularized project for Passive House. It would be very interesting to see how they achieve that building.
It would, and most of their work in the modular space, as far as I know, other than that project, is residential. So it was interesting to kind of see that is something they did.
Yeah.
That's a great idea.
Great.
Yeah.
Great. Thank you very much. I think it's been a great presentation to widen our perspectives.
Yeah, the show is possible and what we can now achieve here in Massachusetts. So thank you everybody for being here. There'll be a recording of this posted with some links here later this week as well, if you want to catch up on what you maybe missed or see some of those videos and subtitles a little more clearly. But thank you for being here, and we will see you again. Take care.